Netra AEW&C Mark II, bigger platform, wider radar horizon. Air battles are won by the side that sees first, fuses fastest, and shares clean tracks to every shooter. India's Netra AEW&C Mark II pushes that advantage by moving from a small regional jet to a larger narrow-body airliner platform, trading up in power, payload, and endurance. The mission stays the same: watch the sky and sea, orchestrate fighters and surface batteries, and close kill chains in minutes. But the geometry changes. A higher antenna, more space for multi-panel AESA arrays, and bigger electrical and cooling margins stretch the radar horizon and the number of simultaneous targets India can manage over contested airspace and littorals. The radar story begins with aperture and altitude. Multi-face AESA arrays mounted to a larger fuselage provide true 360-degree coverage with fewer blind spots and less mechanical burden. More transmit-receive modules mean higher sensitivity, longer range on cooperative and non-cooperative targets, finer beamforming for clutter rejection, and the ability to run multiple modes at once. Wide area search, high update fighter control, and sea skimmer watch near the coast. The bigger platform flies higher for longer, so the line of sight to low-flying threats and to friendly fighters extends by dozens of miles. That extra horizon is the difference between a cruise missile seen in time for an intercept and one that surprises a terminal battery. Surveillance is only half the mission. The rest is battle management. A Mark II cabin lays out more operator consoles, each tied into a fusion backbone that ingests radar skin tracks, identification friend or foe returns, passive electronic support detections, and secure data link feeds from ground and naval sensors. Algorithms promote and deduplicate contacts into a single picture. Controllers assign intercept geometries, hand off mid-course updates for BVR shots, and keep tankers and strike packages deconflicted in crowded skies. Voice circuits ride alongside modern digital links, so a pilot sees the same truth as the controller, and naval combat systems ashore or at sea can fire on tracks the aircraft refines. Endurance and reliability are strategic effects. A larger airframe carries more fuel, more cooling capacity for electronics, and more redundancy. That keeps the sensor on station through crew swaps, weather, and long routing around threats. Air-to-air refueling extends this further, turning a single launch into a day-long orbit if required. With more rack space and power, the Mk2 can host growth payloads, additional passive receivers, wideband comment, improved IFF, or directional data link gateways that stitch disparate networks into one. Electronic support and identification make the picture smarter, not just bigger. Passive receivers geolocate hostile radar and data link emitters without radiating, building an electromagnetic map that complements radar skin tracks and warns when fire control radars light up. Modern IFS and Mode 5 secure interrogations reduce blue-on-blue risk when formations overlap. Over water, maritime modes detect small, fast boats and sea-skimming missiles. Over land, adaptive waveforms and look-down processing pull low flyers out of terrain and urban clutter. Survivability for a high-value node is layered. The Mk2 relies on altitude, standoff, and escorting fighters, but also carries a self-protection suite, missile warning sensors, countermeasures, and emission control tactics that minimize predictability. The aircraft's job is not to be invisible. It is to be indispensable and hard to corner, with procedures that shift orbits quickly when threat rings move. Redundant comms, SATCOM, line of sight, and relays through other airborne or surface nodes keep control alive even when jamming bites. Integration with India's integrated air command and control system is where the investment pays off. The Mark II is a flying router and referee. It cues ground-based long-range radars to sectors that matter, extends the reach of coastal and ship sensors, and gives fighter squadrons precise, constantly refreshed targeting data. Cooperative engagement logic means a surface battery can launch on a track the aircraft maintains, and a fighter can take a beyond visual range shot with mid-course updates from the Mark II, even if its own radar stays silent. In peacetime, the same network polices airspace, escorts civil traffic safely around restricted zones, and builds a library of regional emitters and flight patterns that sharpen wartime detection. The shift to a bigger platform is also an industrial choice. More cabin volume and payload margin make upgrades a software and rack mount problem rather than a redesign. Indigenous AESA technology, mission computers, and operator consoles can spiral faster. Maintenance benefits from commercial airliner ecosystems, spares pipelines, trained technicians, and proven airframes. Over time, block upgrades to radar modules, receivers, and fusion software increase range, track quality, and resistance to deception without changing the airframe. Limits and counters exist. Low observable aircraft compress detection range. Heavy jamming and decoys test fusion and operator discipline. Long-range missiles push orbits outward. The Mk2 answers by teaming. Push fighters and ground radars forward. Hold the AEW&C where it can see and command, and vary orbits and waveforms to stay unpredictable. A bigger radar horizon and more simultaneous tracks do not remove risk. They buy time and options, which is what air commanders trade in. The operational bottom line is clarity at scale. Netra AEW&C Mark II turns more sky into usable information and more information into coordinated action. Fighters in the right place, missiles guided with confidence, tankers and transport sequenced safely, and coastal defense tied into the same rhythm. It is less a single sensor than the pacing node of a national air picture that stretches from the Himalayas to blue water and holds together when pressure is highest. For deep dives on AEW&C radar geometry, battle management networks, and India's path to a resilient air picture, visit globalinfoveda.com.